Hey guys, what's up? Actually, this is the same video, but I had to redo it for y'all. So here we are. We're doing the second problem in my statistics course, and this is Stats 371. If I haven't already told you, over here at NC State University. Hopefully, none of my classmates are watching this because you're not supposed to help out other people with their homework. But I'm not that big; shouldn't be a problem. Alright, so let's see. For customers purchasing a refrigerator, and if you don't know where I'm reading this right here, just 63. See, this goes for customers purchasing a refrigerator at a certain appliance store. Let A be the event that the refrigerator was manufactured in the U.S., B be the event that the refrigerator has an ice maker, and C be the event that the customer purchased an extended warranty. Relevant probabilities are as follows. And they show you them down here. Then the first part says, part A, says construct a tree diagram consisting of first, second, and third generation branches. Fuck my English, dude. And place an event label and appropriate probability next to each branch. Okay, so if you don't know how to make a tree branch, this is how you do it. And we are going to make this as big as possible. And let's see, let's start it from right here. There's my point. Let's start from here. And there's one branch. There's two branches. This is the event that it was manufactured in the US of A. And it's either a yes or a no. Can't really have much of another choice. And of course I fucked up my Y. Oh, Y. There we go. And the probability of A is 0.75. That makes the no 0.25. And then from each of those branches, you get another two branches. And it looks like I'm not going to have enough room, so I don't know what I'm going to do. Actually, you know what I'm going to do? I'm going to erase this. Yeah, erase. I'm going to erase this. And oops, and I'm gonna put US right here, and then I'm gonna put this branch going way up here, and this branch going way up here, and then I'm gonna put, that might not work either because I have to do one more generation, so I gotta, man, these branches are hard, man. Alright, there we go. And this one's kind of perfect as it is. So this one's going to be the event that the refrigerator had an ice maker. So it's going to be ice. Ice, baby. Alright, so let's see. This is a probability of ice given that was made in the US, which that would be a 0.9. So if you don't see that, that's probability of B given A, because this is probability event B. So if this is 0.9, that makes this 0.1. So this is yes, and that's no. And then I can branch those off again, and then this is the last branch, so I can make it as fucked up looking as I want. Alright, and then we're going to have probability of B given that wasn't made in the US, which would be over here, and then that's a 0.8. So let's see, that's 0.8 for yes, which makes 0.2 for no. That looks like a 12. I'll fix that right quick. There we go. And now we have to do one more branch. All right, and then the last one is a warranty. So I'm going to put that as W. And all right, so this is the probability of C given A and B. So like this is probability of A, like yes and no, A complement, B complement, B complement, C complement, and so forth and so on. So this is going to be probability of C given B and A, B intersect A, because both of them have to happen. So let's see, that would be 0.8, that which makes this 0.2. And probability of C given A and B complement is 0.6 for yes. Oh my god, I can't write. Fucking dude, this is hard. 0.6, and that makes this 0.4. And because I mean, the reason why I say that is because if you have the probability of an event happening, you know, if you add up everything in that possible range, it has to add up to 1. So you either have to be in the U.S. or not be in the U.S. You can't be in the U.S. and out of the U.S. or you can't be like there's no in between. So if you add them up, it should be 1, like a probability of 1. And that goes for every single branch, given every single path that you can go down. And I didn't mean to make that mark. See if I can Control Z it. There we go. I don't want that. All right. Now this is the probability of C given A complement and B. So that would be this one right here, 0.7 for yes. And that makes this 0.3 for no. And then this one will be the probability of C given A complement and B complement, because neither one of them happened. So that would be 0.3, as shown over there, for yes, and that makes it 0.7 for no. And there you go. You have a full tree diagram. And now I got to copy it, so just give me a second. I don't have enough room. Fuck you, paper. I see how it is. US. Yes. No. 0.75. 0.25. Then we branch off again. For ice. Yes and no. 0.9. 0.1. Then we branch off again for warranty, and I don't have enough room again. Fuck this paper. Fuck all of you. Fuck your mom. Fuck your dad. There we go. I wish I could show you what it looks like on my paper. And then this is warranty. And that's going to be yes, no, yes, no. Then I need to do this one. So that's going to be, oh God, made that way too big. So that's going to be 0.8 and 0.2. And then that's going to branch out. Yes, no, yes, no. And that's going to be 0.8, 0.2, 0.6, 0.4. 0.7.3 and 0.3.7. All right, there we go. Oh god, it took me 10 minutes to do that fucking problem. Oh my god. Alright, compute the probability of A intersect B intersect C. Well, that's just the probability. Okay. So the probability of A intersect B intersect C is equal to the probability of A given that B intersects C. Shit. Never mind. No. Can I make this any bigger? Like, really? Can I just, like, just select this and erase it? Oh, here it is. And there goes my phone. Alright, we don't want to do that, because we don't have any probability for that. What we want to do is say that the probability of C happening given that A and B happened. Alright, so doing this, and then if you multiply that by the probability of... Fuck! Are you kidding me? Oh, wait. Are you kidding me? Alright. I see how it is. So, turns out that our good old buddy, probability of A intersect B doesn't actually exist here, which really sucks. So now I'm confused. Compute the probability of A intersect B intersect C. Well, I can get the probability of B. Does that help me any? I don't know what to do. Let's see. I mean, this is redonkulous, dude. This is just straight up redonkulous. Like, in class, this shit was so easy, and now on the homework, it's like, nope, never mind. Alright, guys. Alright, this might take me more time than I thought it would. I might split this up into 2 different videos here. Fuck this problem. That's all I gotta say. So we got the probability of C given A and B. That A and B happened. So the probability that A, B, and C happens is just going to be the sum of the first line of our tree diagram, but that's not enough for me to show my work. Like, I can't show which... Oh, shit. Yes, I can. I can do that. Oh, shit. It's going to be the probability... Like, I don't know why this works. Well, we're going to see. Times probability of A times the probability of B given A times the probability of C given A that B should be equal to that. So let's see. So this is the probability of B given A times the probability of A. So that's going to be the probability of... Wait a minute, let me look at my notes. So let's see. No, right here, probability of A intersect B is equal to the probability of A. No. Probability of A given B is probability of A intersect B over probability of B. So if you take this and you multiply by this, you should get that, which is what we did here. So that's the probability of A intersect B. What's this? And then this piece right here, whoops. Anyways, that piece right there is probability of, that's basically the same form as this. So that's the probability of, hold on, I need more room. Man, y'all see how fucking hard my work is? So this is probability of C intersect A intersect B divided by the probability. Oh, I see why it works. The probability of A intersect B. So when you multiply that times this, these cancel out and you get this probability. No wonder why it works. Okay. Alright, the guys, we figured this shit out. See, it took me only 10 minutes to figure that shit out. Oh my god. Y'all are gonna be watching for hours. Oh god. But hey, at least I can show y'all why. Like, I really don't know what I'm doing here. I'm just like going in trying to get my homework done. Man, I want to take a cigarette break though. Might do that after this. Alright, so the probability of A intersect B intersect C is equal to the probability of B given A. No, probability of A. Probability of A times probability of B given A times probability of C given A intersect B. And this is because this piece is equal to the probability of A intersect B, and this piece is equal to the probability of C intersect B intersect A all over the probability of A intersect B. Multiply that out. These cancel out. It's equal to this. So that equals 0.75 times 0.9 times 0.8, which now I have to get out my phone to do. 0.75 times 0.9 times 0.8 is 0.54. And blammo, we got our answer. Alright. So this one, that was a doozy. Anyways, this one is the probability of B intersects C, which looks a lot easier, but I don't know. Like, this is probably going to be harder than the last one, for God's sakes. B intersects C. Oh my God, my handwriting is terrible. So that should be equal to... Let's see here. What can we do? So, last time... we cancel out shit. So, like, this one's just a... I don't know what to do. Like, I really don't. I mean, I gotta write down something. Like, I guess this could be expressed as a probability of B given C, but we don't even have that shit, times the probability of C, or I mean that's the same thing, but we don't have that. Like we can get, like, let me look on my diagram here. Let's see, the probability of B given A and A complement. Like, we got all the probabilities here. So this is B intersects C, so B and C have to happen. So according to my tree diagram, the only place where that happens is one line plus the second line, and that's it. Like I don't know why this is, again, and I'm gonna have to prove it again, but let me rewrite this, make it a little bit neater. Like, man, I can't believe I need help like this. I need to use a tree diagram in order to do this problem. I feel ashamed. So this is the probability of B intersects C, therefore B and C have to happen. So I'm going to add up all the branches where B and C both happen, which is going to be equal to the probability of A given, I mean, no, not given, times the probability of B given A times the probability of C given A, probability of C given A and B, plus the probability of A complement times the probability, well, that means it's not A, that it was not made in the U.S., times the probability of B given A complement times the probability of C given A complement and B. Now, I'm going to show you that this works. So, the probability of A is just the probability of A. But the probability of... Oh, wait, I'm sorry. So, the probability of this... Oh, that was a terrible one. But yeah, the probability of this is the probability of A intersect B. Wait, what? Wait a minute, this doesn't work. I don't know, maybe it does. Okay, so the probability of B intersection C, either probability of A happens or probability of A doesn't happen, but both of them are in there. So, anyways, you'll see in the end. Anyways, that's the probability of A intersect B. This is the probability of C intersect A intersect B, all divided by the probability of A intersect B. This cancels out. So we got the probability of the intersection of all of them. But now in this one, if you do the math, which I'm not going to do it for this one, because it's the same exact thing. It's the same exact thing that happens. The only difference is that this is A complement, and that's A complement, and that's A complement. That's the only difference. But anyways, if you do the math, that this will also become probability of C intersection A complement intersection B. So, if you add them together, C intersect B. If you add them together, you got you got A happening and you got A not happening, which means that it doesn't matter whether A happens or not. Anyways, this is equal to let's see, 0.75. No, you can read it. It's over here. So it's equal to 0.75. Hold on, actually. Is equal probability of A times probability of B given A times probability of C given A intersect B plus the probability of A complement times probability of A B given A complement times probability of C given A complement intersect B, which is equal to the probability of A complement intersect B intersect C plus the probability of A intersect B intersect C, which is equal to 0.75 times 0.9 times 0.8 plus, let's see, plus 0.25 times, where am I reading it? Okay. 0.8 times C, there we go, 0.7. which is equal to, hold on, well, 0.775 times 0.9 times 0.8 is equal to 0.54, and 0.25 times 0.8 times 0.7 is equal to 0.14. You add them together, and you get 0.68. Bammo. We're done with that. Alright, so the probability that C happens, well, according to my tree diagram, I'm just going to skip, well, fucking no, I'm not going to skip it. I'm not going to take the lazy route. Damn, and I still got like 4 more problems to do. This one's already taken me 31 minutes. Let's see. So the probability of C happening is, let's see. Well, damn, we're going to have to add 4 things. I'm going to go ahead and skip showing y'all this one, but if you refer back to the tree diagram, here, I'll redraw it for you. Let's see. Bam. So if you refer back to the tree diagram, you had this, yes, no, yes, no, yes, no, and yes, no, yes, no, yes, no, yes, no. And it said that we have a 0.75, a 0.25, 0.9, 0.1, 0.8, 0.2, 0.8, 0.2 again, .6, 0.4, wait, oh, whoops. Yeah, that's not what I meant. 0.7, 0.3, 0.3, 0.7. Well, the probability of C is every single time that C occurs, it needs to be added. So that's 4 different lines. So that means I gotta add this line, then I gotta add this line, then I gotta add this line, and then I gotta add this line. So give me a minute while I go ahead and put all the lines down. So 0.75 times 0.9 times 0.8, that's equal to 0.54, 0.25 times 0.1 times 0.6 is equal to 0.015, Oh, that was 0.75. Whoopsies.
Why won't you answer?
Sorry guys, that was my mom calling, and yeah, she calls at the worst times. Alright, let's see, probability to see. Oh yeah, that's right, I was doing this on my phone before my mom called me. 0.75 times 0.1 times 0.6 is equal to 0.045. Okay, that's not too bad. Just add a 4 right there. So then 0.25 times 0.8 times 0.7 is equal to 0.14. Then 0.25 times 0.2 times 0.3 is equal to 0.15. Add these all up. Alright, so 0.14 plus 0.045 plus 0.54 is equal to 0.74. So it's a 74% chance that you will have a warranty, like a random person selected from a population will have a warranty on their refrigerator. Blammo. Hold on, I just gotta write this out. .015 plus 0.14 plus 0.45 plus 0.54 is equal to 0.74. Alright. Okie doke. And we got one last part to do. Oh, I didn't know that I could do that. I mean, what happens if I zoom out? Oh god. Man, that kind of sucks. Okay. Alright, so the last question says, compute probability of A given B and C, the probability of a U.S. purchase given that an ice maker and extended warranty are also purchased. So, again, well, the probability of A, given that B and C happen, oh my god. Let's see. Let's go ahead and do the math on this. Probability of A given B and C is equal to the probability of A intersect B intersect C divided by the probability of B intersect C, which we already calculated in a previous problem. We know that that's equal to 0.68, and we also calculated this to be the to be 0.54. So we know this is equal to 0.54 over 0.68. And according to my calculator on my phone, 0.54 divided by 0.68 is equal to 0.79 and about half, but I'll just put 79. And let me go ahead and write that out here. 7, 9. Almost a half. Just a let's see, tenth, hundredths, thousandths. Just 10,000ths of a 9 10,000ths. So it's about a thousandth of a percent off from being 80. Well, being rounded up to 80. So 0.79. So 79% chance given that your refrigerator, given that your, no, the 79% chance that you bought your refrigerator in the United States of America, given that your refrigerator has an ice maker and you bought a warranty. Pretty random ass information if you ask me. Now I'm just copying it down. .79. Cool. That finishes up that problem. That took me 42 minutes, guys. A little bit less for y'all because my mom called. Alright. Anyways, I will see you in the next problem. I don't know whether I'm going to put them all together or not, so I'm going to start off the next problem, though, as if it was a new video, because this has already been an hour long.